The worst volcanic eruption of the last 10,000 years happened south of Japan. Not in recent memory, not in recorded history, but in a geological instant, 7,300 years ago, a caldera on the sea floor between Kyushu and Okinawa tore open with a force that buried all of southern Kyushu under pyroclastic flows. Ash fell across 2 million square kilometers. It reached Hokkaido, 1,700 kilometers to the north. It reached the Korean peninsula. It reached the Pacific Ocean. The Jomon people who had lived across southern Kyushu for thousands of years were effectively erased. The land needed roughly 1,000 years to recover. That caldera is called Kikai. It is mostly underwater. It is 20 kilometers wide by 17 kilometers across. On March 27, 2026, a team from Kobe University and JAMSTEC published findings in Communications, Earth, and Environment, confirming that the same magma reservoir that fed the eruption 7,300 years ago is being refilled with new melt right now. Japan Meteorological Agency is maintaining an active crater warning on the island that sits on Kikai's rim today. Not a future risk, a current one. The numbers from the original eruption are difficult to absorb at first. The Akahoya eruption produced between 332 and 457 cubic kilometers of volcanic material, enough to fill Lake Tahoe twice over. The dense rock equivalent volume sits between 133 and 183 cubic kilometers, roughly equivalent to covering all of Tokyo's metropolitan area under a layer of solid rock 35 meters deep. The eruption had a volcanic explosivity index of 7. That puts it in the same category as Tambora in 1815, the eruption that caused the year without a summer and crop failures across the northern hemisphere. Kikai's Akahoya event is larger. Pyroclastic flows, walls of superheated gas and rock moving at hundreds of kilometers an hour, crossed 100 kilometers of open ocean to reach the southern tip of Kyushu. Tsunamis generated by the caldera collapse reached sites with tsunami deposit evidence more than 300 kilometers away. Communities that had existed continuously for thousands of years were gone. That is the template. That is what Kikai has done before. And today, on the volcano's northwest rim, Satsuma-Iojima, a real inhabited volcanic island, is sitting under Japan Meteorological Agency Alert Level 2. White plumes are rising up to 600 meters above the crater rim of Iodake, the island's central cone. Nighttime incandescence is visible on monitoring cameras. On December 29, 2025, there was an eruption at the crater. The restricted zone extends to within 500 meters of the summit, where the Japan Meteorological Agency warns of large ballistic ejecta, ash, and volcanic gas. The volcano is not dormant, the system is active, and now the deep reservoir beneath it is confirmed to be filling. But here's what the new data actually showed. The Kobe University team didn't drill into the caldera. They didn't need to. Working from research vessels, the Kaimei and the Kaiyo Maru, and from the training ship Fukae Maru, they fired AR gun arrays into the water. These are controlled seismic pulses, essentially artificial earthquakes sent into the seafloor on command. Ocean bottom seismometers placed across the caldera floor then listened to how those waves moved through the crust beneath Kikai. What they found was a low velocity anomaly. In seismic imaging, that means the waves slowed down because they were passing through material that is partially molten. Rock conducts seismic energy well, magma-laced rock conducts it poorly. The team found the anomaly directly below the inner caldera at a depth of 2.5 to 6 kilometers, less than the distance from the seafloor to the bottom of an average city's water supply infrastructure. The melt fraction sits between 3 and 6%, possibly as high as 10%. In a reservoir of this scale, that is a significant volume of active melt suspended in crystal mush. Seama Nobukazu, the lead geophysicist, said the reservoir's location and extent make it clear. This is the same magma reservoir that powered the Akahoya eruption. Not a new feature. The original structure. Still there, still filling. The evidence for active reinjection comes from the caldera floor itself. At the center of Kikai, a lava dome has been growing for 3,900 years. Its volume now exceeds 32 cubic kilometers, roughly equivalent to stacking the entirety of Mount Fuji twice over. Chemical analysis of the dome material shows it is compositionally distinct from the magma that erupted 7,300 years ago. It is not a remnant. It is new material, injected from below. The team calculates a long-term melt injection rate of more than 8.2 cubic kilometers per thousand years. The reservoir has been accepting new melt consistently for nearly 4 millennia. Seama's model may not be unique to Kikai. The same shallow reservoir architecture, large, close to the surface, actively receiving injected melt, has been identified at Yellowstone and Toba. Yellowstone's Magma reservoir sits between 3 and 8 kilometers depth. Kikai's reservoir sits at 2.5 to 6 kilometers depth. If this pattern holds across all major caldera systems, it changes how scientists need to monitor them. The current signs preceding a giant eruption may look similar across different calderas. Kikai is the clearest case study right now because the last eruption was recent enough to be well documented in the geological record. The surface expression of this system is not a plume of seafloor vents or a distant thermal anomaly. It is a cone, a real volcanic island rising out of the caldera rim. Satsuma-Iojima, also known as Iojima, sits on the northwest edge of Kikai's rim structure. Its summit crater, Iodake, has been active for as long as monitoring records exist. The Japan Meteorological Agency has kept Satsuma-Iojima under some level of crater warning continuously for years. Alert Level 2 means the exclusion zone is active, and approaching the crater within 500 meters of the rim is prohibited. A plume height of 600 meters reported in the March 27 status note is not an anomaly. The volcano routinely vents. The nighttime incandescence means the crater is generating enough heat to glow in darkness, even without a full eruption event. The eruption on December 29, 2025, was a sharp reminder that the current warning level is not precautionary theater. The alert level remained at 2 afterward, meaning the Japan Meteorological Agency assessed the ongoing risk as sufficient to keep the crater exclusion in place. The Japan Meteorological Agency also announced on March 25, 2026, that it was revising Satsuma-Iojima's alert level criteria, effective March 31st. The revision reflects updated assumptions about where vents might appear and what hazard zones need to cover. That is not a reduction in monitoring, it is a refinement. Scientists now believe the eruption scenarios they need to plan for are more varied than the previous criteria assumed. The Kikai system has been building since before the most recent caldera forming event, and it has not been quiet since. Records of activity at Satsuma-Iojima trace back to at least 1934, when an eruption occurred. In 1935, renewed activity followed. The island sits in the middle of one of the most tectonically active regions on Earth, the Ryukyu Arc, where the Philippine Sea Plate is subducting beneath the Eurasian Plate. Every year, the subducting plate carries more fluid into the mantle. Every year, the conditions that generate melt in the first place are being refreshed from below. The lava dome inside the inner caldera has been growing continuously for 3,900 years. It did not pause. It has not shown signs of decelerating. At 8.2 cubic kilometers per thousand years of melt injection, in 3,900 years, the system has added the equivalent of a mid-sized stratovolcano worth of material to the shallow reservoir, and none of it has erupted at scale. That is not a countdown. It is not a prediction. Nobukazu Seama is careful about this. The paper is not a forecast. It is a mechanism description. How the reservoir fills, what the architecture looks like, how the same structure that was emptied 7,300 years ago has rebuilt itself. The team's goal is to get closer to recognizing what precursors to a future giant eruption might look like, before that eruption is imminent rather than after. That distinction matters. Right now, the shallow reservoir is 3 to 6% melt. For comparison, Yellowstone's current melt fraction estimates run between 5 and 15%. Kikai is not at the threshold that produced the Akahoya eruption. Nobody has established what that threshold is. That is the honest position, not panic, not dismissal. A system that has been recharging for 4,000 years, that produced the largest eruption of the current geological epoch, that still has an active crater under official restriction today, and which science only just confirmed is filling in the same reservoir with new melt right now. The question is not if Kikai erupts again. The question is when the monitoring gets precise enough to know before it does.